There are a few terms on global climate change, looking at a positive feedback loop and a negative feedback loop. Let's first look at a positive feedback loop. And this representation is great. It's really one thing increasing, causing another thing to increase. Positive, positive. So as your births increase, your population size increases. And as population size increases, so does the number of births. So it's this one thing causing another to increase. All right? We could look at it here with climate change. As more carbon dioxide, methane release into the atmosphere, temperatures increase. As temperatures increase, permafrost decreases. And permafrost contains methane and carbon dioxide, so you're going to release more carbon dioxide. Constant positive feedback loop. One thing causing another to increase. Looking at a negative, same situation. It's one thing causing another to decrease. Disrupt sleep. You guys staying up till 2 in the morning. Causes fatigue and diminishes the ability for your body to deal with stress. And by not being able to deal with stress, you can't sleep. So your sleep decreases. Once again, this is a negative feedback loop where one thing causes another thing to decrease. Positive feedback loop, one thing causes another increase. Negative feedback loop, decrease. Few questions on sewage treatment plants, and got a great diagram here. So we are moving left to right here, and we've got primary, secondary, and tertiary treatment. Secondary and tertiary. Where does wastewater come from? It comes from flushing the toilet. So as you use the restroom, your water and that water goes to a wastewater treatment plant. What would the first thing be, or primary things you want to get out of your wastewater? You'd want to get out solids. And the way to do that is by screens, catching it there, or allowing it to settle just down at the bottom. So as that primary treatment continues, goes on, and then you still have a last settling stage where the sludge, and this can be either taken to a landfill, and then sludge, which is the more less dense stuff like poop, goes down to a sludge digester we'll talk about in a second. Then when you get to secondary treatment, this is really the use of bacteria. And bacteria are a main component of what cycle? Think of the biogeochemical cycles. What would bacteria take out of a system or remove? Yeah, they remove a lot of nutrient pollution like nitrogen and phosphorus. And they call it aeration because bacteria doing cellular respiration need a lot of what? They need oxygen. So you add oxygen into it, bacteria thrive, and then they're going to take out a lot of this nutrient pollution. But as you go on, you still might have some solid particles or dead bacteria, so you allow it to settle once again, and it goes down to the sludge treatment again, which is, we'll talk about in a second. And then the last one, which I'm going to encompass in here, is disinfection. It's getting rid of the bacteria, or getting rid of really bacteria or anything living or protozoa. And way to do that is by spraying it with chlorine gas. All right, so that's Cl2. You got it here. Or hitting it with ultraviolet light. Those two ways, they decrease bacteria. All right. Write that here. Bacteria. I'm writing with my foot, by the way. Just kidding. The only problem with this, with the whole wastewater treatment plant, is that it doesn't remove one thing. What do you think that is? Yeah, that is pharmaceuticals. So any type of drug, synthetic drug that individuals might take for some health issue, as they digest it, it goes through the system and possibly releasing it as they do their business, that goes to a wastewater treatment plant, and that whole process does not remove pharmaceuticals. All right, last one that we were going to talk about is sludge, and that's from the primary and secondary. That is then compressed as fertilizers. So that is really the poop, which then is turned into fertilizers. That's then sent to agricultural fields. Primary, removing solids. Secondary, removing nitrogen and phosphorus. And then tertiary, removing bacteria by chlorine or ultraviolet. Sewage treatment plant. Wetlands can be a natural way of doing sewage treatment. So if we have a wetland here coming in, you have your first treatment that would be primary. And primary removes solids. Then you have plants doing secondary, which you can have bacteria too as well here. But then plants can be used as phytoremediation. The term up here. What does phyto mean? It means plants. And what does remediation mean? Look here. Remediation means to clean up. Let's put them together. Plants clean up. Phytoremediation. So that's used in secondary treatment with bacteria to get rid of nitrogen and phosphorus. Right? Plants can use the nitrogen and phosphorus, they'll grow, and then as water continues on, some of that nutrient pollution is reduced. You can have another solid removal stage here. The last one, tertiary, is the only one that we intervene with, where we're going to add our chlorine gas or ultraviolet to get rid of the bacteria. Wetlands, how they can be used as a sewage treatment plant. Phytoremediation, plants cleaning up. There was another question looking at the mercury and mercury cycle and its main source, where it comes from. Remember, as things and matter moves in a ecosystem, they tend to cycle. Well, where is the highest point source of mercury? Well, it's from power plants. Power plants is the highest. Second highest is incinerators, but number one is power plants. And since mercury is so dense, much more dense than air, it settles in low-lying areas, so that's why it gets into waterways. So that's why pregnant women are advised not to eat raw fish, because as they accumulate in waterways, they can get into algae that then are consumed by small fish. Let me do my arrows properly the right way, showing energy transfer. And then as they are accumulate into fish, they then can have exposure into humans. Mercury can cause a lot of issues in young children.